Imagine falling into a black hole. You get all twisted up and stretched out like spaghetti, and then meet your doom at the center of the universe. But there's another possibility. The black hole could wipe away your entire existence from reality itself.
Yeah, that sounds insane.
But it's actually a very serious issue in physics known as the information paradox, and it might mean that we don't really exist at all. So let's talk about that. This is our channel. Black holes are weird. They're places where gravity is so strong that nothing, not even light, can escape their grasp. And they're also bizarre because they seem to break the laws of physics. See? When something like a star collapses and makes a black hole, all of its matter gets squished together in a place called the singularity. We don't really know what's going on in there because physics, as we know it, just doesn't work under those extreme conditions. It's kind of like when you see an image that's been pixelated because it was compressed too much. The information is still there if you have the right software to decompress the image. But if the image is infinitely pixelated, then the information is irretrievably lost. And this seems to be what happens inside a black hole. And here's the kicker. That isn't just a problem for the stuff that falls into the black hole, but also for the information that escapes, aka Hawking radiation. In 1972, Stephen Hawking made a shocking claim. He said that black holes aren't entirely black. They emit radiation because of effects near the event horizon. Basically, empty space is never truly empty. There's always particle-anti-particle pairs popping in and out of existence. When one member of the pair falls into the black hole and the other escapes, the radiation carries information about the stuff that fell in. This was groundbreaking because it meant that black holes aren't completely black. They emit radiation because of the effects near the event horizon. Basically, empty space is never truly empty. There's always particle-anti-particle pairs popping in and out of existence. When one member of the pair falls into the black hole and the other escapes, the radiation carries information about the stuff that fell in. This was groundbreaking because it seemed to suggest that black holes didn't destroy information after all. However, in 1974, Hawking changed his mind. He now claimed that black holes do destroy information and are therefore a violation of the laws of quantum mechanics. Here's why. In quantum mechanics, every property has a corresponding uncertainty. For example, the more precisely you know where a particle is, the less you know about its momentum, and vice versa. These uncertainties are linked together by the famous equation, the uncertainty principle. Now, if you've got a bunch of particles all bunched up together, like the stuff inside a star that makes a black hole, their uncertainties are all jumbled together too. But when the particles spread out, their uncertainties spread out as well. When you compress a gas, for example, all the molecules are squished together and their properties are uncertain. But when you let the gas expand, the molecules spread out and their properties become more certain. That's just how things work in our universe. But this doesn't work in a black hole. Because according to Einstein's theory of general relativity, nothing gets out of a black hole once it crosses the event horizon. This means that the uncertainties of the infalling particles can't spread out, so the information that they carry is lost forever. But wait, you might say the particles aren't destroyed, they're just stuck in the black hole. Well, yeah, that's true. But remember, in quantum mechanics, a property can only be uncertain if you haven't measured it. Once you do measure it, the uncertainty goes away, and you learn something definite. So if you were to try to measure the properties of the stuff in a black hole, you wouldn't be able to find out anything new. It would all be a big, fat zero. And that's the crux of the information paradox. How can you destroy information without actually measuring it? One possible solution is that the radiation coming off of black holes actually does carry information about what's inside them. Unfortunately, the math behind that idea is super complicated, and most physicists think it's just not correct. Another possible solution is that our entire universe is a hologram. Stephen Hawking himself suggested this idea back in 1993. The basic idea is that everything we see around us, including ourselves, is nothing but information encoded on the surface of a black hole. According to general relativity, a black hole's surface area can never decrease over time, so the information contained on it must also be conserved. This means that all the information in the universe could, in principle, be stored on the surface of a black hole with a surface area equal to the size of the observable universe. This idea isn't as crazy as it sounds. After all, we already know that empty space is full of virtual particles that pop in and out of existence. It is possible that these virtual particles could be used to encode information on a black hole's surface. In fact, physicists have found evidence that black holes seem to have holographic properties. In 2016, researchers at the University of Vienna used a quantum computer to simulate the evaporation of a small black hole. Their results supported the holographic principle, suggesting that the information content of the black hole's surface equals the volume of its interior. But there's a twist. While Hawking radiation does seem to support the holographic principle, it also seems to contradict it. Hawking radiation comes from quantum effects near the event horizon, but the holographic principle says that all the action should be on the surface of the black hole. What gives? Well, it turns out that the information paradox might not be a paradox after all. In 2021, a group of physicists proposed that black holes don't destroy information, but they do erase reality itself. Their paper shook the foundations of physics, and the implications are staggering. Let's break it down. First off, the researchers refined a mathematical framework for understanding black holes and quantum mechanics. Then they applied this framework to a thought experiment involving a particle that falls into a black hole. To describe the particle, they used a mathematical object called a state vector. A state vector contains all the information needed to describe a quantum mechanical system. Position, momentum, spin, the whole 9 yards. Now, when the particle falls into the black hole, the state vector gets all twisted up and stretched out, just like the spaghetti metaphor I mentioned earlier. But instead of being stretched out in space, it's stretched out in what mathematicians call Hilbert space. Don't worry, we won't go into what that means exactly. Just know that it's basically a fancy way of describing all the possible states of a system. Anyway, when the particle reaches the singularity, the state vector becomes infinitely tangled, which means that it describes a state that can't be broken down into simpler states. It's a fundamental state. And here's the kicker. This means that the particle no longer exists as an object in space. It's gone from being something with definite properties to something that's fundamentally undefined. The information about the particle isn't lost. It's just not in any form that we could ever observe. In other words, the particle has been erased from reality. And this isn't just true for the particle, but for anything that falls into a black hole, including light. This means that black holes can literally erase reality itself. But here's the final twist. If black holes can erase reality, then our own reality could be erased too. The researchers pointed out that the human brain is basically a black hole with a lot of quantum effects going on in it. So if we fell into a big enough black hole, we wouldn't just be destroyed. Our entire reality would be destroyed along with us. But wait. You might be thinking that we QE and actually fall into a black hole, because that would take infinite energy. And you'd be right. But the researchers argued that this is only true for point-like black holes. Real black holes have a finite size and mass, which means that they have a finite amount of gravity. So it is possible to fall into a real black hole. And if you did, you'd be erased from reality itself. Now, before you start worrying too much, this is still just a theory. And even if it's right, it's not like we're gonna fall into a black hole anytime soon. But it does raise some deep questions about the nature of reality. Is it real? Or are we just a bunch of information floating around in a black hole? Who knows? Maybe one day we'll find out. 4 more shocking space mysteries. Follow our channel. We release new episodes every week.